Just a little recap on general functions. So from what we've just seen, what type of function is each of these ones?
Ooh,
that one
is a linear.
That one wasn't in the dance. It is kind of looks linear, but it's, yeah, you can get it. Yeah, it's a constant function. Yeah. Vertical line. It'll be in the form of like y equals a number. So it's y equals whatever it cuts through.
Does anybody a sharpener, please?
What kind is the next one? Obvious. You can tell by the equation too.
It's a linear.
It sure is. And the next one?
Negative linear.
Yeah, it's negative linear. Yeah, so think about negative linear or linear. And this little thing?
Quadratic.
Quadratic. This little cutie?
Cubic.
Cubic, yeah. Does this one have a maximum and minimum, or does it have a point of inflection, this one, do you reckon?
Inflection.
Yeah, it's one of the ones that has like a point of inflection.
What does that mean?
Point of inflection, like that little woody there, right there. It'll have a point of inflection. So you know, normally a minimum and a maximum. If it's a minimum, it would go up and then it would go down. Or if it was a maximum, sorry, if it was a minimum, it would go down and then up. So this is kind of like a little turning point kind of thing, but it's got a special name. Point of inflection, because C was up and then it still kept going up. So that particular one's got a point of inflection, but overall it's a cubic. That one?
Absolutely.
There's another name for it.
Modulus.
Yeah, modulus, yeah. So you can put both if you want.
What?
I tend to call it.
Our exams.
I use absolute value. Yeah, that's what I tend to use. Modulus is just a regular one. That sounds fancy, but same one again, yeah, you're right. Absolute value. Like a negative of it. Next thingy. Overall, what kind of graphs are these little thingies? Such as
Trigonometric.
Yeah, that type of trigonometric. Yeah. Trigonometric. Sine of x. Trigonometric. Yeah, that's an exponential. Yep. So this one's just an exponential. Exponentials have horizontal or vertical asymptotes. Which is if you're not sure. A little guess. It's horizontal. Good guess. So exponentials have horizontal asymptotes. So horizontal. Okay, horizontal asymptote. What's the base of that one? Of this particular example, what's its base? E. E. Yeah, E is just a number. Remember, like 2 point blah 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 blah, 2.7 blah blah blah. Yeah, exactly. So it's a E. If you were to solve that one using logs, would you use the common log or the natural log?
Natural
log. Yeah, when you're dealing with it, you would solve it with the natural logs. Because then something like L and E might cancel out to 1, and then you get a nice simplified function. Because if you solve, if it was a solving question, but it's not. So that, by the way, is meant to be a horizontal asymptote. Huh?
Okay, so you see the way it goes like absolute value and then it's negative absolute value. How's there a negative absolute value?
Oh, yeah.
You smart.
Because what it's done is whatever the y value was for this one, it's just said make the negative of that. So that's why it's instead going down like that.
So negative absolute values are not impossible.
The absolute value part is just this part.
Yeah.
And then what they take is the negative of that answer.
So it's not negative absolute value per se.
Yeah, exactly. Yeah, absolute values have to be positive.
So
But
it's
what
kind of
they
like
do-
negative 1 times your absolute value.
Yeah, exactly. Like negative 1 times your absolute value.
So
You're right.
there's an invisible 1.
Yeah, exactly. So there is no such thing as a negative absolute value. So what they do is they do negative 1 multiplied by the absolute value. And that's how it ends up kind of like slipping down. What kind of graph is this thing? Isabella, what kind of graph is this one?
Is it the negative 4?
It's just logarithmic, yeah. You can just say, just overall, what is it, kind of thing. So we'll just say logarithmic. Is it a natural log or a common log? In that kind by the equation.
It's natural?
The natural log, yeah. So overall, it's still just logarithmic. Do logarithmic functions have horizontal or vertical asymptotes?
Vertical.
Yeah, vertical, yeah. And what's the relationship between the two functions we've just looked at? They're friends? They're friends in a way, they're connected in some kind of way. They're inverses, good. These two are they're the inverses of each other. If you reflected this thingy, if you reflected this one in the line y equals x, do you see that? If you reflected this one, the exponential one in the line y equals x, you would get the logarithmic line. So they're inverses of each other if you want to make a note of that.
Wait, what did you say this was?
If you reflected the inverse one, sorry, the exponential one, guys, thanks. If you reflected the exponential one in the line y equals x, you would get that one.
Yeah, you would.
So these two are actually inverses of each other.
Yeah, what is it actually?
Okay, x equals 0, yeah, it's just a constant one. It's just a constant function again. And it's a constant function that cuts through. If it did, actually, the way it's drawn, it's not x equals 0. That's a mistake. What should it be instead of x? Yeah, it's y equals 0. Good.
Wait, why is it y equals 0?
Because it cuts the y-axis. That line will cut the y-axis. It won't cut the x-axis.
Wait, so why can't it be x equals?
Because the way his arms are.
Oh.
He's horizontal, yeah. He's a horizontal one. See, this one is a horizontal line that cuts through the y-axis of 1.
So if his arms were like going the other way, then it'd be
Yeah.
And why is it 0?
So if he was able to somehow do this. Oh, they just said, like, you know, it would look like on a
so
graph.
it's along the axis line.
Yeah, exactly. It's going to be technically the x-axis. Technically, it'll be this line here.
That's probably why they did say it.
Yeah, that's it. Technically, it'll be that red line. Yeah, so that was a mistake. It shouldn't be x equals 0. What kind is this guy here?
Reciprocal.
Good, yeah, reciprocal. They have horizontal and vertical asymptotes. So they're kind of like, it's hard to draw it with the way you stand. Probably like that. So 2 types of asymptotes. What value of x is not allowed mathematically?
0.
Yeah, because you can't divide by 0. So hence that's what generates kind of like the asymptotic, the vertical one, because you can't divide by 0. And 1 divided by a number, will you ever get 0? Like 1 divided by 10 million is still just 1 10 millionth. It gets closer and closer to 0. So that's how you get a horizontal one. Like the number 1 divided by anything at all won't get you an answer of 0. So that's how you get a horizontal asymptote. So horizontal and, probably want to write that, horizontal and vertical asymptotes. Okay, what kind is this little fella? Yeah, cos? Yeah, yeah. The overall kind of like umbrella term. Trigonometric. No asymptotes or anything. Normally a cos starts like this, like that. It's kind of like how a cos starts. Cos graphs tend to start more at the maximums, whereas sine graphs are the same graph, but they start in the halfway point instead. What kind is this one? The line is linear, yeah. It's a normal linear one. That's not very exciting. Same thing, linear. What's the relationship between these two linear graphs? It's a transformation. What kind of transformations happen?
Translation.
Yeah, translation, yeah. Or transformation, same thing, yeah. It has translated, yeah. What kind of transformation? It is a translation, you're right. So, how many units did it translate? 2. And in what direction? Yeah. Oh, vertical or horizontal?
Wait, what are we?
The relationship between these two?
Oh, if they're
Yeah, it went like
together.
that. Yeah. So see, it's
Oh,
kind of
okay,
like,
I was
it's
really
done that,
confused.
and then it's just the same graph, you just step down 2 units. So that represents as Calvina said, translated 2 units.
Because it's linear and then it would move up one and then move down one, so it's just the same.
Yeah, if it was x plus 1 and then it became x plus 3, then it would have moved up 2 units. So it's all to do with that number, the constant term that tells you the vertical.
Wait, so if it was x plus 1 and x plus 3, wouldn't it move up 4?
Yeah, it would have been a plus 1 and then it's moved up plus 3. So from 1 to 3 there's 2 units, yeah. Whereas from 1 to negative 1, it's gone down to 0 and then down to negative 1. So that's why it went 2 units down here.
Times it moves. Never mind.
Yeah, I can also show you on here, like x plus 1 would kind of look like that. X plus negative 1 would be parallel but like that. Except I didn't draw it very well to scale. Negative 1 and 1. So it went down to 0 and then down to negative 1. And then it translated 2 units in the negative y direction. So it's a vertical translation. And a fancy way to say it is translated this to this has translated 2 units in the negative y direction. This thing's kind of hard to see, but it's meant to be like that. What kind is that one? Oh, and the last one. Maybe look at that one. Help. Starts with Q. Yeah, and anyone, how do you know if it's quadratic? Yeah, the x squared, yeah. The highest power of x is a square. Is a quadratic. If the highest power of x is a 3, then it's cubic. And if the highest power of x is a 4, then it's quartic. So a little review of a lot of different functions so far. And asymptotes, as I said, today we're doing a bit of reciprocal stuff. So reciprocals having vertical and horizontal asymptotes. And there'll be, within here, there's a bit of translations as well, because reciprocals tend to go pretty well with translating. Okay, let's go on. Am I recording this? Yeah, I'm good. Okay. In the space below, draw a sketch of the reciprocal function and write out its general equation. See page 3 and 4 if you forgot. So page 3 and 4, like you know, on the first pages of your booklet. And what are some features of this type of function? So by features, one thing that might be important to mention is what we've mentioned on this guy here. Oh, you can see, because remember you've got the thing. Do you mean, hang on, I'll just pause. Recording, ready, here we go. So page 3 and 4 of the booklet is kind of like when we were back here. So the reciprocal function you can see kind of generally looks like this. We also drew in vertical asymptotes and horizontal asymptotes. So we have a vertical asymptote. Why do we have a vertical asymptote again in terms of the equation? Yeah, exactly, can't divide by 0. So in this case, there'd be a vertical asymptote through x equals 0. And there'd be, why is there a horizontal asymptote at x equals 0?
Is there a horizontal?
Yeah, why is there also a horizontal asymptote at x equals 0? It was to do with, we mentioned it on the guy that was dancing. Yep. So this one is because you can't divide by 0. What was this one for again? It's hard.
I don't remember.
Yeah. Why will 1 over x never equal 0?
1 over x?
Yeah.
Oh, because you will keep getting close to 0 but won't get there.
Yeah, exactly. Like if you had a negative number, like 1 divided by negative 1, it's just going to get you a negative answer. You wouldn't get 0. If you did 1 divided by 100 million, you'll get closer to 0. You get close to 0, but you never actually get to 0. So 1 divided by anything will never reach 0. So this is a general graph. I want you to do the general graph of the sketch. General sketch of the graph, I mean. And the general equation, you could just say y fx equals 1 over x. Did we also do it down here? Sometimes people say k over x instead, because it doesn't have to be 1 on the top. It could be 3, it could be 5. So if you prefer to call it y equals k over x because it doesn't have to be a 1 on the top, it's okay if you want to just write it as y equals 1 over x too. So the general one, let's make a little vague sketch of it so you can vague sketches. So you need your x-axis and your y-axis. But don't forget to label your x and your y in that bit of that. Am I drawing my asymptotes now too? What is the equation of this vertical asymptote? Good guess. Really good. Really close. X equals 0, yeah. Good. It cuts the x-axis.
Not following what
Yeah, it cuts
go
the
through Y.
x-axis. It doesn't cut the y at all.
Okay.
Well, technically this one's kind of going through the y as well. But what they mean is, if it's a vertical line, it's always x equals something, because it cuts the x-axis if it's a vertical line. And the horizontal asymptote, what's its equation? Yeah, good. Y equals 0. This is for the general reciprocal function. I'll use 1 over x. It's okay if you do k over x. You'll have the same asymptotes. K would just be a different number, like 3 over x or 4 over x. And then
Mine too.
so see this line, it's closer and closer to 0, and then it kind of bends around. Thanks for you guys. Pay attention, please. And then this one gets closer and closer to 0 and sort of bends around too.
So.
Huh?
Right.
Yes. So as x gets bigger and bigger, the y value is going to get closer and closer to 0. And as x gets smaller and smaller, like 1 divided by 0.00005 is going to be a big number. Because how many times does 0.00005 go into 1? It goes in heaps. So that's why as x gets closer to 0, it gets higher. And as x becomes a bigger number, the y value gets smaller. Plus there's another section. Which section should I be drawing in? There's another part that I haven't drawn. Yeah, the left bottom, yeah. Because negatives, 1 divided by negative numbers will generate negative y values. So when you do a number divided by negative x's, you'll get negative y values as well. So similar thing. Just
Wait, so it's the x equals 0 is because you can't divide by 0, and it's the y equals 0 because no matter what 1 is divided by, it will never reach 0.
Yeah, good. Yep, that's a good point. So that might be worth a little note why these things. So because this one is because you cannot divide by 0. So Chuck Norris can divide by 0. And this one is I see because 1 divided by any number could never equal 0. Or you worded that in a way that makes sense to you. 1 divided by any number could never equal 0. That's why we get the horizontal one. It's a wonky my picture, isn't it? Very well drawn axis. So it's kind of like that one's kind of flipped over that way. So this one's getting closer and closer to that vertical asymptote and getting closer and closer to the horizontal. Kind of flips around like that. That's our little reciprocal function. So the function is y equals 1 over x, or y equals k over x will generate the same style. Y values might be just slightly different. So you're multiplying by k. So yeah, what are the features of this type of function? So something you might want to say is they have vertical and horizontal asymptotes. It has a vertical and a horizontal asymptote. And if you've written the reasons, you don't need to say why again. In terms of the features, another thing you could discuss is domain and range. Domain and what's its range. And again, double check that I like this expressed in SL. Domain, is it XER?
The x doesn't touch 0.
Yeah, exactly. So there's a value, it's XER except for that. Oh, yeah, you could write two different ways. X is greater than 0 and x is less than 0. True. Yeah, you could write it like that. Or some people write XER but then they write x is not equal to 0. Or sometimes you'll see it written like this, just straight up like that. X cannot equal 0. That's kind of the slack way that I've done it in the past.
I remember that.
Some people are a bit more thorough. They say XER, but X is not allowed to equal 0. If you also say what Krista said, that would be right. X is greater than 0 and X is less than 0. That also would work. But this is the cheap, short way that I've sort of tended to do it in the past. And it's range. Is it YER?
The same thing, so y doesn't equal 0.
Yeah, y can equal 0, yeah. That's kind of the cheap, short way. I should double check if that's still fine in SL to write it like that. I'll let you know if it's not. But that's the way we've kind of written it a lot in the past. Is there anything else really to it? Nothing really. Like, it's curvy. Doesn't seem to have maximums or minimums. Like, nothing really that exciting. I think that's the main things. If you can notice anything else exciting about it, feel free to make a note of it. They were the main ones I wanted you to notice. You could say it has a left arm and a right arm, that kind of thing. I'll let you know, an arm. Sometimes they call them arms. Like quadratic graphs have 2 arms, kind of thing. Like this arm and this arm. Yeah, they call them arms, isn't it? Interesting. But yeah, it's like, not a big deal to mention those things. So that's a general form of a reciprocal function. What is an asymptote? I think you guys realize this, but just in case you don't.
That's funny.
Oh, this thing? Oh! I really thought you were talking about the title. Isn't that good? He's the asymptote. He's the asymptote. The graph below. Oh, wait. What would be the equation of the reciprocal function below? What are you guys doing? So what it's asking is, what would be the equation of the reciprocal function below? And because it's been transformed, imagine it was, you could say k over x, but let's say maybe originally it was 1 over x, just for fun. Has it moved sideways at all? No. Has it moved vertically at all? Yep. How many units did it all move up? How many units did it move up? From compared with the original, that one. Yeah. Yeah, like relative to y. 2. Yay. And so it might help you to sort of see what's going on. This is our little thingamajig. So you kind of use the asymptotes a bit to decide what kind of transformations have happened. And it's missing an asymptote. Where should the other asymptote be?
Oh, 0.
Yeah, no, okay, it's missing that one. So we should probably draw that in. X equals 0. What's this asymptote's equation now?
Okay, so
Yeah. So what's the equation of this graph? Let's say it was 1 over x to begin with. Plus 2, yeah. You just throw a constant at the end. Plus 2. That's it. Y equals 1 over x plus 2, because everything's just shifted 2 units vertically. So let's assume it was 1 over x. We didn't know whether it was 3 over x or 4 over x. So let's just say it was 1 over x to begin with. So what would be the equation of the reciprocal function? So in that case, you can say fx if you want. 1 over x plus 2. And this is assuming that it's 1 on the top. It could have been a different number like 3 or 4, but we don't know. So let's assume it was 1 over x.
if it was a different number, how would that affect the graph?
Yeah, it might make it kind of swoop up faster. So if it was a number other than 1, like 3, then it's going to get higher faster. So it'll kind of get higher faster. If it was less than 1, like 0.5 over x, then it won't take as long. It'll take longer to become high. Go up high. Sort of increases the rate of change. There you go. That's all it was asking, wasn't it? So translate it 2 units up. So we could say as the horizontal asymptote had shifted 2 units up as well. Shifted 2 units up. And also, if you've got space, you can say there's no horizontal transformation. So no horizontal translation or transformation. So that's why it's still just over x. If it had moved sideways, then you would have x plus something or x minus something underneath in the denominator. But yeah, the constant gives a vertical shift, and the x being added or subtracted to something down there gives the horizontal shift. So there's no horizontal translation. Oh, and it said the graph below is missing a second asymptote, which we just drew in yellow. What should be the equation of this asymptote that it was missing? I think we said it, yep. So Isabella, what would be the equation of the missing asymptote that we drew in?
Y equals what x minus?
Of the asymptote, the dot dot dot.
Oh,
Yeah.
was this one or that one? Y equals 2 or y equals x?
For the graph below, yeah. So it was missing the asymptote. So the one we were missing was, that one's there, the horizontal one there, it's missing that one, yeah. X equals 0, yeah. So it's actually, yeah, x equals 0, because it was the vertical one. The vertical one was missing. Because the horizontal one was drawn. We just coloured it in here. And we've already drawn it on the graph. X equals 0, because there was no horizontal translation, so it just stayed. It would have been, it was just 1 over x. Is an asymptote actually part of the function? It's a very good, interesting question. Probably no. It's a part where the function can't exist, isn't it?
It's what?
It's like a spot where the function can't exist.
Okay.
Yeah. So instead, it's a line or a spot. Yeah, spot, an area, yeah, exactly, where the function can't exist. Region, another mathing word, it's a region where the function can't exist. I think technically an asymptote is normally a line, so it's a line where the function can't exist, but sometimes if I write the word line, people think that therefore the asymptote itself is a function. So it's not part of the function, instead it's just a spot where the function can't exist. And we just put the dot 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 line to say that this is not the function and it's not allowed to touch here. The function is in red in the graph below. So it's all pretty straightforward. Yeah, so the function is a red bit. The asymptote, the yellow dot dot dot, is not the function, it's just the region where the function can't exist. Yeah. Next bit. On the previous page, what does MC Hammer say about the asymptote? Yeah, okay. That'll do. The function can't touch the asymptote or cross it. Use the equation for the reciprocal function, see top of previous page, like y equals 1 over x plus 2, to explain why MC Hammer says this. So again, it's kind of still just trying to reiterate 1 over x plus 2. So it's trying to reiterate why there's an asymptote. So what kind of asymptote was MC Hammer? Was he vertical or horizontal?
Horizontal.
Yeah. Yeah, so he's horizontal asymptote. And as I said, people tend to remember quite easily why there's a vertical asymptote because you can't divide by 0. But people tend to forget why there's a horizontal one. So that's why I've put it in here again. So why can't the function touch y equals 2?
Because
Yeah.
y can equal 2.
Yeah, y can't equal 2. Yep, there's no value of x you can sub into that. So we'll end up with an answer of y equals 2. Yep, so you can just write that in your own words.
Wait, I don't get it.
Yeah, so there's no value of x that you could ever sub in to this function that would get an answer that of y equals just 2. So consider it like 1 divided by anything. Like for y to equal 2, 1 over x would have to be 0.
But you can't make it 0.
Yeah, exactly. You can't divide 1 by anything and get 0 as an answer. Yep. So you could just say you can't divide by 1 by anything to get 0. So, yeah. Or you could just say it in your own words if you want. It's more for something you to look back on and be able to understand. There is no value of x. That will make 1 over x equals 0. So it's not possible. For y to equal 2. Yeah, so specifically the asymptote at y equals 2, because it's impossible to make 1 over x equal 0. Because there's no number you can sub in for x. 1 divided by anything will never get 0. So just get values that are close to 0. Anything. It's a weird idea. To get closer and infinitely closer to something but never touch it. I'll just pause that while people are running. So about to start recording. Here we go. We're recording. So why can Chuck Norris touch it?
Who's the star? By 0.
Yeah.
Why can he do it?
Yeah, because he can divide by 0.
Yeah. So he's telling MC Hammer he can touch this.
Oh, he's telling MC Hammer. MC Hammer is saying he can't touch it. Yeah, okay, got it. That's confused.
Okay. Find the equation for the following reciprocal functions. Ugh. First of all, what would be the asymptotes?
0.
There's no shift, is there? So I don't know what k is, and I can't be bothered finding what k is right now.
K.
Oh, k is like the general idea. It's y equals k over x. So k could be a number. Like the function could be y equals 1 over x is a general one. It could be y equals 3 over x. It could be y equals 7 over x. Or k being a constant.
This girl's street.
Who's
I mean, who's she playing? Who is she playing? Say Meryl Streep.
So y equals k of x. So we know that there's no shift. We know that there's no +1 or there's no horizontal vertical shift. So we don't know what k is. If you were to find k, you would have to take a point and you sub in y and x and solve for k. Do you want to do that? Are there any points that you can see they're clearly a coordinate? But that one's 10. 1, 5. Oh, yeah, that's a good one. Yeah, let's sub in 1 and 5 and see what happens. So we could solve for k. See this cool little point here? 1 and 5. We can plug in x and y. Because we know, so what we're doing is like...
We find out K?
Yeah, to find out what k would be. 1 and 5, yeah. Let's plug in x and y. And let's solve for k. So we can find out, is k just 1? Is it a number, different number? Okay, so y, 5 equals 5. Okay. Oh yeah, that's not exciting, is it? Okay, so it ended up being that k equals 5. So k equals 5, so our final thing will be y equals 5. Yeah, you got 5 over x. Yep, so you want a coordinate that's really clear. If you wanted to check, you could check it with another coordinate if you had the time. always a good thing, but that was meant to be an obvious coordinate for you. So yeah, so it is possible that the number on top might not be 1. But unless you've got information like a coordinate or something that you could plug in to solve the K, it's hard to know. But we do have a nice coordinate. Now solve for K.
No.
Yeah, okay, this is what we're doing. Ah, yes, yes, you may. And is there been any transformation here? Any kind of horizontal or vertical translation to your record? Has it moved upwards or downwards?
You mean
What has moved upward and
right,
downward?
sideways.
Yeah, that's right. It's only moved compared with a regular like x equals 0, y equals 0. Yeah. So I tend to sort of like look at the asymptotes, like where the asymptotes might be. So it hasn't shifted up at all because we've still got
It's moved to the right.
yeah.
Wait, is it like stage?
So there's been no, you're right, no vertical shift. So there's been no vertical shift because we've still got the same horizontal asymptote.
So
But
when it's shifting, it's us looking at it, not us being the graph.
Because if we were to say, we would say
It's
it's
right.
right, but you would also say it moves stage left.
us looking at it, yeah,
Yeah.
looking at it, yeah, not from the perspective of the graph.
So
Yeah,
how we
right.
wrote stage left would it be wrong?
Stage left. Whatever makes sense to you.
Yes.
Because
Well,
that,
I don't know.
but so long as your equation comes out right, so long as the equation you write is correct. So I would say normally it's from the perspective of looking at it.
Okay.
It's normally, if you were to describe it in words, it would be from the perspective of looking at it.
This one has been here always.
Been there for weeks, actually. Like,
Is yours?
So just by a vague, it's meant to be just a vague look at it. Where do you think the asymptote, the vertical one's cutting? One, yeah. I'll say 1, 2. So our vertical asymptote is x equals 1.
I don't mess up everything.
So how does that change our equation? Oh, we don't know what k is, so let's just leave it as k. K over. And the horizontal shift appears in the denominator.
Did you make that?
Did I say horizontal? What? Me? Did I say horizontal? I don't even know I said that. So the horizontal shift appears in the denominator.
Yeah, because it's x plus 1.
Yeah, so it's moved to the right. Therefore, remember it's the opposite sign for vertical. No, vertical follows the sign. It's the opposite sign for horizontal.
X plus 1.
Yeah, it's x subtract 1. Yeah. And has there been any vertical shift? No. Nothing.
So can you, because
Yeah, we could. Oh, 2 and 1. You found a nice coordinate. That's a great idea. Yep, 2 and 1. That's a brilliant one to solve for k. So let's plug in 2 and 1, x and y, and solve for k.
yeah. I mean, I just wanted to be
K over. And then we solve for a k. What does k equal? Oh, so it's just a boring one. Okay, so our final equation would be.
So why is it x minus 1?
1 over x. Wait, that's not right.
Oh, yes, gotcha.
Yeah, why is it minus 1? Yeah, because horizontal translations are in the opposite direction to the sign that they give. Vertical shifts are in the same direction as what it says. So if it says plus 2 for the vertical shift, it's gone up 2. Whereas horizontal is in the reverse.
Just after your home, she said we should be together.
Oh, the asymptotes aren't drawn
No,
very
Miss
nicely.
Monica, please.
Scroll up. Sure. So see the horizontal, the asymptotes, they've kind of done in solid lines. We should do them more like dotted lines, so let's correct it. There you go. So we realized what the translation was, and then we found a nice coordinate, 2, 1. That's a really nice obvious coordinate, and then plugged it in. And itself a case.
Wait, what was the point of plugging in again?
To work out, is it just 1 on the top, or is it a different number? Yeah, because k, it's a constant, it just has to be a number. So it could be like the one above, it ended up being 5 on the top instead for the one on the top of the page.
Yeah.
Yeah.
I know you're sad and tired.
What is this? What's the horizontal asymptote equation?
Y equals 4.
Yeah, wait, 4. What's the vertical?
X
Was
equals
2.
2.
Yeah, was it? Yep, I'm glad you know that. I was going to say 1, but yeah, you're right.
So
42.
Y equals K. 2 plus 4.
Oh my goodness. Okay, so it's got this translation. So it's K. We don't know what K is yet.
Maybe this is minus 2.
Wait, why is it
Why is it
minus 2?
Because
Because it's to the right 2, so
Yeah.
you need the opposite.
Or you could be to the right.
Oh, that's what you were saying.
Yeah.
This one means that's just y, because we're not negative y.
Our coordinates could be
Yeah, that's part of the asymptote, the little thing. So I'll be right.
Oh.
Yeah, it was just a dash from the asymptote. So y equals 2.
Shut it.
So now, do we have a nice coordinate?
3, 5.
3, 5. Cool. That sounds good. Yep, 3, 5 sounds good enough. Let's use 3 and 5. So we use 3, 5. Raise up x and y.
So it's 5 equals
Okay, cool. So Sarah's identified a coordinate, a good one, like 3, 5 is a nice one to sub in. Nice whole numbers. So we've subbed in. Put it in green in case you're wondering what's going on. Yeah, we just get a boring answer.
I did it wrong.
It's 1 again. Oh no. So we got a normal 1 answer. 1 over x minus 2 plus 4. So don't forget to write the equation at the very end. You can write fx equals whatever the axis says. Our axis didn't say anything. Is that the last page?
No.
There's another one.
Two more.
Oh my gosh. Oh cool, we've still got 10 minutes. Some people are writing that down.
This mommy, I think you really pre-printed the exact same pages.
You did.
Did I?
Yeah, like 1, 2, 3, 4.
Go. Okay, now we're going to start to draw some graphs on the next page. Yay. Oh, use technology. Great. Get your little graphs out. So that's the good thing when you see use technology. Makes life so much easier. I'll just pause and I'll open up mine. 2, 3. So now use technology to graph the following reciprocal functions and find the equations of any asymptotes. So get out your little calculators is what it's asking. They want you to go y equals. If there's anything here, you need to clear it. So do you know how to make the nice fractions, like 1 over x minus 1? I'd suggest use a fraction box. How do you get your fraction?
Wait, Miss, I have a question. Y equals.
Yeah. And yeah, that's it. Good. Yeah, yes?
Changing your visit changes how zoomed in or zoomed out you are?
Yeah, that's it, yep. X minus 1, good, and then arrow out of it. So I've made a mistake on mine. If you can see it, can you see what mistake I've typed in? It's a bit hard to see from there, isn't it?
You first subtract.
Subtract 2, yep, I put plus 2. So I always have a little check. Oh, I cleared the whole thing by mistake. Don't do that. I should have just deleted instead. So 1 over. Always look at it before you press graph. So before you press graph, look at what you've typed in. Because it might look a bit dodgy. Might not be right. Minus 2 instead of that. You could just go to graph or you could adjust your window. Does anyone have any ideas? Like, I know why, but anyone want to guess what I need to do to get rid of this scatter plot that's interfering? Good, yeah. Second, yep, that's it, yep, second stat plot. And I've got a plot on, so I need to switch it off.
What?
Second plot, yeah. And it's all because I had a scatter plot.
Sorry.
Yeah, so second y equals, yeah, second y equals, it's a stat plot. So if you've got any plots on at the moment, it's going to interfere potentially with the graph you're about to draw. So second y equals gives us that, and then you open it up and you switch it to off and make sure you select off. Don't just flick to it and then not press enter. Then you can graph the little thing. I can't see mine very well, so what can I adjust? Window, yeah. So imagine, like, didn't tell us what to do it for. Like, normally a question would tell you. So if they said minus 10 to 10, I'm like, no, I'm just going to do minus 10 to 10. But the questions in exams, they'll normally tell you minus 10 to 10. Sorry, and negative 10, I should be saying. Negative 10 to 10, which, by the way, is Zoom standard. If you go Zoom standard, it takes you negative 10 to 10.
So what should my window be, Miss?
It didn't tell. Normally the question asks you, but this one didn't. So I said, let's just go minus 10 to 10 on the x-axis and minus 10 to 10 on the y-axis. Ooh. Ooh. I'm being so excited. I know on the TI Inspires, like the new calculators, if you trace, then the asymptotes pop up. Have you ever found ways to find asymptotes using this thing? Like if you trace these little babies, will it eventually come up with an asymptote? It doesn't? Oh, that's a shame. It just jumps onto the next arm, doesn't it? So it won't tell you that it's undefined or anything at a certain point. Yeah, whereas the new TI Inspires, at some point it stops and it says UNDEF for undefined once it's hit the asymptote.
Oh, you can
Did mine
you
provide
can
an
look at it in the table.
asymptote?
Ah, table, that's it, yeah, table, good idea. So let's,
second graph,
yeah, second graph opens up the table.
Error.
and there's an error at 1.
Thank you, good memory, well done. So yeah, I can't see mine, so I just scroll until I can see the error. So that tells us there's an asymptote at 1.
But how do you find the other one?
Yeah, how do you find the other one? It doesn't seem to find the other one for us. I think that's a limitation. It doesn't seem to find the other one. I think we just have to have a good educated guess. Yeah, go to the table, that's it. So it seemed to be the only one we've been able to find is the vertical asymptote. It's only going to tell us the vertical one at x equals 1. But unfortunately, it doesn't seem to tell us the horizontal one. We just have to have a nice educated guess. So an educated guess, if I was really stuck and I just didn't see the equation and I wanted, like obviously it's at the horizontal one's at -2, but if I didn't see it, I would just trace along here and just see what is it getting closer and closer to, or trace along there, either one. If you trace along it, you can kind of just see for the horizontal one, it's see the y value is getting closer and closer to 2, but it's not touching 2. Same with the other arm, it's getting super close to 2. So tracing seems to be, a way that you can kind of find it. Tracing gives you a good idea, roughly. And so on or whatever. Okay, so use technology and then just do a little graph of the thing. I'm going to be lazy. Second trace. Oops, graph. And I'm just going to take a snip of this. I'm going to take a snip of that. So you guys draw yours though. Make it bigger. And let's draw in our little asymptotes. So you guys have noticed there's an asymptote at x equals 1 by doing the table. Maybe make little instructions. If there's any instructions you want to write down for what you did, like y equals, clear any stat plots. The fact that, like how Grace just reminded us how you can double check the asymptote. It's like you press table to find the vertical asymptote. The horizontal one, the only thing we could do was trace. But we can also see from the equation what it is. Y equals -2. So this one, we press table. Table and look for error in Y column. So that's the way Grace remembered to double check where an asymptote, a vertical asymptote is. Go to table and scroll up and down until you see the word error somewhere in the Y column. That tells us what the X is. To find this one, all you can really do is trace. Trace along and just have an educated guess. There's a trace button on your calculator. There's a refresh table for that one. Yeah, oh, and my graph's missing my X label and my Y label. it's 12:20, so we'll finish. But it takes a while to do these, so we'll pick it up next lesson.